Alright guys, in this video we are going to continue talking about E, or Euler's number, and natural log. Okay, so we have a word problem here, so why don't we go ahead and read it and then we'll talk about how we can break this down so that we can solve it. Alright, it says a paleontologist uncovers a fossil. He analyzes the fossil and determines it contains 25% of its original carbon-14. Carbon-14 has a half-life of 5,730 years. Determine the age of the fossil. Alright, so before we start getting into this problem, there are some knowns that we can use to help us solve it. And one of those knowns is going to be the natural decay function that we have here. Okay, so just to be clear, this isn't something that we just pulled out of a hat. This is real. Okay, so this is called the natural decay function. And before we start talking about this function, we're going to label the variables on this function. So for example, n of t, we want to know what that is. Well, that's going to be the remaining amount of carbon. So we're going to say remaining amount. So remaining amount, and that's going to be of carbon-14. This n and this subscript O is going to be the initial amount. So initial amount. And then we just have E, okay? And then we have this K here. Okay, this is going to be called our decay constant. So decay, constant. And then we have t here, which is time, so time. And our time is going to be in years, so time. And again, this will be in years. Alright? Alright, so taking a look at that, why don't we go ahead and try to fill out these variables based on the information that we have. So it tells us that we have 25% of its original carbon. So that's going to be the remaining amount, 25. So we're going to put 25 here. Well, if this is the remaining amount, what must have been the initial amount? And that's going to be 100, right? So 100%. And then we have E. And then we're going to have minus KT. Notice I don't have these values because look at what they're asking. They're asking for what was the age of the fossil, determine the age of the fossil. So they want to know the age of, so they want the time here. We're not given the time. So that's what we're trying to find. We're trying to find the time. I also have another unknown here, my decay constant. So I'm running into a bit of an issue here. I have two unknown variables. And I can't solve this if I have two unknown variables. So we have to go about doing this another way. So let's go ahead and erase this because we can't use this yet. Alright, so we're going to have to come back to this. Alright, so let's erase this. So what we're going to have to do here, we're going to have to solve for the decay constant first. And once we have the decay constant, then we can go ahead and solve for the time or the age of the fossil. Okay? So let's think about this. Let's go back to the problem and see what it says. Well, right here it says carbon-14 has a half-life of 5,730 years. So it has a half-life of 5,730 years. So for example, if you started out with 100% of carbon-14, after 5,730 years, that will be at 50%. So based on that, I have a remaining amount, I have an initial amount, and I have a time. My time is going to be 5,730. My initial amount is going to be 100, and my remaining amount is going to be 50, right? That makes sense. Half of 100 is 50. Okay, so let's go ahead and put in those values. So I'll have 50 equals 100, and then I'll have E minus K, and then my time, which we said was going to be 5,730 years. Okay, so what we want to do at this point, we want to isolate this e. So we're going to divide both sides by 100 here. So when we do that, we'll have a half, right? 50 divided by 100 is a half. And then we'll have e. And let's multiply this out here. We'll have negative 5,730 k. All right? So now I want you to think back of your properties of logarithms. Remember, natural log acts just like a logarithm, okay? So it has the same properties. And think about how we can get rid of this e here, because notice that my k is where the exponent is, so we need to work on getting rid of this e. How could I get rid of that? All right, so take a minute and think about that. And if hopefully you got it, we're going to take natural log on both sides, okay? Because remember, natural log, so if I just said ln of x, well, natural log has a base of e. So this really has a base of e. So it's really ln of base e. Okay? So knowing that, we can use the inverse properties of logs. And if I take natural log on both sides, this e will naturally cancel out. Again, that goes back to inverse properties of logs. Okay? So let's go ahead and do that. So I'm going to take ln of 1/2. And then what I do to one side, I have to do to the other side. It is an equation, right? We have to balance it out. So then we do ln e, right? Minus 5,730. Okay. And again, we talked about inverse properties of logs. This is simply going to cancel out again because this really has a base of e and they're inverse, right? So this is going to cancel out. And now we're left with ln 1/2 equals negative 5,730. Okay. So at this point, we're just simply going to divide both sides by negative 5,730. So you're going to have ln of 1/2 divided by negative 5,730. Let's go ahead and put that in our calculator to see what we get here. So we take natural log of 1/2 divided by negative 5,730. Okay, and we get an answer here. And our answer is going to be, so we get decimal here, so we're going to get k, we're going to write it right here, k equals 0.0001, and we have 209, okay? So that is what k is going to equal here. So knowing that, we have it recorded. Let's go ahead and erase this work now. We're going to repeat this process, but now we're going to solve for the time, okay? So now that we have the decay constant, let's go back. It says they want to know, they want you to determine the age of the fossil. It says that the fossil, he analyzes the fossil and determines it contains 25% of its original carbon-14. So the remaining amount here is going to be 25, so we're going to put 25. So if this is 25, what was the initial amount? Well, that must have been 100. And then we have E, and then we have our K right here, so minus, so put this in parentheses, minus 0.0001209, and times our time. Okay. So we're going to go about business as usual. We're going to divide both sides by 100. We want to isolate this E. So when we divide each side by 100, this will become 0.25. And we have a similar setup as last time. So we'll have negative 0.0001209. Alright, so we're going to take natural log on both sides. So we'll do natural log of 0.25 equal to natural log E, again, negative 0.0001209t. Again, this will cancel out. Okay, so now that we got it to cancel out, I'm just going to simply rewrite this so I have more room to work. Okay, so we're going to erase this top part here. And let's put what our remaining values will be. So we'll have ln of 0.25 equal to negative 0.0001209 t. Alright, and now you're simply just going to divide both sides by this number here, right, on both sides. So let's go ahead and do that. So we're going to do ln, or natural log. So let's do natural log of 0.25 divided by, we're going to do negative 0.0001209, and we get a number here. So our time here is going to be 11,466 years. Okay, that is your final answer here. Alright, and that is it.